every AI breakthrough you have seen in the past decade is still needed a human in the loop. And sometimes it's recommended to have a human in the loop, but sometimes it can also limit what AI can do. For example, a researcher is reading papers, running experiments, deciding what to try next, and then he or she has to go and actually execute it. What if AI can do all of that itself? What if AI can take the next step? AI can improve itself. That's not a thought experiment anymore. Hexo Lab has built SIA, or self improving AI, which is the world's first open source agent that teaches itself how to improve without waiting for humans to show it the way. And today we have with us Kunal Bhatia, CEO and co founder of Hexo Labs, to talk about what that actually means and why it could change the pace of AI development entirely. Kunal, it's great to have you on the show.
Thanks so much, Swapnil. Great to be here. So Hexo Labs is basically a research lab. We're building self-improving AI systems, and with the goal that if AI can build itself and build better version of itself, we would be accelerating to the path of superintelligence, which could potentially have amazing benefits to humanity as a whole, and potentially create abundance for all as well.
Before we get into SIA, talk a bit about Hexolab. What are you building and what problem are you trying to solve?
So it's fundamentally most AI agents that you see today are designed by AI researchers and engineers, whether it's at the model weights level, which is to actually train the model, or whether it's to actually design the harness or the memory systems or the architecture of the entire system itself. Right? They are very skilled human beings who are at the top of their field, very elite researchers and engineers who are building these systems. Our belief is that today, with the current technology we have, we do have the ingredients for the system to actually inspect different parts of itself, which include the model itself, the architecture of the code that's written around it, which is today called harness, and the agent itself should be able to kind of inspect this and build improving versions by giving itself feedback. And what we are basically designing is this entire architecture and system which can do this.
The idea of AI that improves itself sounds almost like science fiction. Actually, I'm a science fiction author myself, so I actually feel that we are behind. We should have been here already. Super intelligence, flying cars should have been here, but they are not. Can you talk about where did this idea come from? I am assuming some science fiction did play a role here, and are there real world precedents for this?
Yeah, so I think that this idea has been seeded in society since a while. We've seen a lot of sci-fi films. We've seen research papers, which, like for example, the Gödel machine, which came out in 2003. The research paper actually, although theoretical, spoke about a self-improving software system where you basically say that this is the last software system that we build as humans, because then it can start improving itself. I think all technology till date has kind of been leading up to this point where these machines can start building themselves. And of course, we're talking only about the software landscape right now with AI, but you club that with robotics, and then you have a combination where you have hardware and software which can start building each other and building the overall system together. So I think the idea from a societal perspective has been seeded for a while. For us as a company, I think we've been AI researchers for over a decade now, myself and my co-founder, and we've seen the entire journey. We've built multiple AI systems in this period, and at some point, the question came is that, okay, why don't we actually try to replace ourselves? And that's where at least the seed for what we're trying to do kind of went on from.
CI stands for Self Improving AI. Walk us through how it actually works and what does it mean for an agent to teach itself?
So I think there are three or four different parts that make up an agent itself, right? One is the underlying model itself, the weights of it, then the harness, the memory system, the skills that the agent has, and the tools that it has access to, right? These five components actually just fundamentally make up agents. And of course, I'm not even talking about the backend infrastructure right now, right? So as of now, we've kind of seen agents being able to write code really well. And fundamentally, if you look at all these five components, they are code, right? So if agents already know how to write code, they should be able to write code which drives the agent itself. Most agents, as I said, so have been designed by expert humans. So I think a lot of you might have seen, a couple of months ago, Andrei Karpathy came out with the auto researcher, and he tried to automate the research part of AI itself. But the interesting thing in this was that a human and someone of the level of Andrei Karpathy was actually writing the agent itself. So interestingly, we decided to take that as one of the problems where we're benchmarking, and we took Karpathy's auto researcher agent, we took our agent, made both of them compete on a similar problem. And our agent was not specially designed to do AI research. It's a general purpose agent that can self improve itself towards any problem, right? And we saw remarkable performance gains in actually the general purpose self improving agent that was able to actually beat uh, Karpathy's auto research agent. So we're talking about a general purpose self improving agent beating an elite researcher in his field, right? We're talking about someone who's at the top of their field, and agent beating them. So I think it just starts. It's staring at us right now in our face.
Excellent. No, thank you. And one of the most exciting thing that you folks are doing is also releasing it as open source. That's kind of big decision. Talk a bit about the reason behind making this infrastructure publicly accessible as open source.
So I think that there are a few companies and large companies which are obviously trying to build self-improving systems and super intelligence in some way, right? I do think that it's not the best option for humanity to just have it be concentrated in the hands of a few. These systems should be available to everybody to uh, be able to own these systems in a sovereign way as well. If just three or four companies own this kind of technology, I'm not sure it's a good idea. And the technology being available for the rest of humanity also to be able to access it in a sovereign way, right? Of course, you can access it through APIs or through applications that these companies build, but that doesn't ensure your sovereignty.
You have partnered with Stanford and UC Santa Barbara on this. What role do these research institutions play, and what does the scientific advisory board bring to the table?
So I think one of the things for us is that if we are trying to build self-improving systems, right, the most important thing is to test it on extremely hard open-ended problems, because that is where most agents today fail. And the bottleneck is actually expert humans, right? But the irony is that you actually need expert humans in the beginning to seed the system and to make it capable enough and to evaluate it to be able to solve some of these problems. So that's why we've been working with top labs across Stanford, UC Santa Barbara, Oxford, etc., to actually have them design problem statements which are extremely hard, which the agent can solve and the system can solve, and evaluate its capabilities as well, right? And build that initial feedback loop into the system. So it was very deliberate to actually work with some of these places because they actually are working on bleeding edge, open ended problems.
You folks have also launched the Hexo Grant program. Who is that for, and what does it give researchers access to? What do they get through it?
Yeah, so it's actually for researchers similar to the ones we just spoke about, researchers in labs, which are working on bleeding edge problems across new energy sources, new computing frameworks, new material sources, biotechnology, all of these different areas and more, right? We are actively looking to work with some of these researchers, and we're giving them access to self-improving systems plus a lot of compute infrastructure on which they can run a lot of their experiments and to accelerate their research work as well.
And can you also talk about where does SIA get applied first? Are there any real world use cases that you can share where companies can engage with, or where you can see, hey, this is what is already happening, this is already improving AI in these use cases?
So I think one of the things which we are underestimating right now, especially with a lot of the AI industry and where the investments are going, a lot of them are point in time solutions because I think AI itself, right? It's not just a platform change. The way we move from personal computers to mobile phones, or from on-premise infrastructure to cloud. It's not just a platform change. I think this is a fundamentally civilizational change because we have not even seen the full breadth of the capabilities of AI yet, right? We're talking about something that is a step function change from like hunter gatherers to farmers to industrial to now, super intelligent systems, which means that the way we operate is going to fundamentally change. I think we saw this a couple of weeks ago when Anthropic announced Claude Design. Figma's share price just tanked, right? So it's interesting here because it's not Anthropic which is competing with Figma. It is Claude, an agent that is competing with not just Figma, but the entire industry, right? So most enterprises which are still figuring out what's going to happen with AI, or how to actually incorporate AI. It's not about, the previous debate of whether it's like humans using AI better than other humans or whatever, right? That's not the case here. It's not humans competing with AI. You need AI to compete with AI. So I think fundamentally organizations would have to, reimagine themselves from the grounds up, probably dismantle the previous systems they worked with, which means that you need to have your own sovereign superintelligence, which can figure it out, right? So if in this case, where the example which I gave you, if our self-improving AI system was able to beat Andrei Karpathy, which is an elite researcher in their field, I think a lot of business decisions as well, and any function within an organization, and AI will probably do it much, much better than, the best humans in that field as well. So I think being able to get hold of these kind of super intelligent systems is super important. So I think the business case attacking anything today, there is a very serious threat that you might get rolled over by the next release of an advanced system. It's important to kind of design your own system and your approach in a way that would be relevant in the future as well.
Let's talk about once again humans. If AI starts improving itself autonomously, what is the role of human in that word? Of course, humans are designing it, and AI can never be AI for the sake of AI. You have to serve a customer base, and that customer base has to be human because AI cannot just pay for it. But talk a bit about what does this mean for researchers? What does it mean for, let's say, college graduates who are looking at software development or AI as a career? Because we don't even know what the world will look like in 2 to 3 years. A lot of low-level jobs are already gone. Companies are not hiring because that can be done very easily with AI, and there is nothing wrong. We always like to optimize things. But talk about where do you see human in this SEA word?
I think it's very hard to say, right? Because it's like when we were a farming society, it was hard to say what the industrial society would look like, or if you ask hunter gatherers, what does a farming society look like? Like there's a fundamental change in our own understanding of who we are, right? The frameworks we have and the perspective we've built and the knowledge we have is based on the current reality we've lived in, but that reality itself would potentially change if these systems become widespread and are able to gain these capabilities, right? Which means that even something like why do we have jobs is because there is some sort of scarcity and we need to fulfill our needs over that scarcity. But if these super intelligent systems are able to get rid of scarcity in a way that you can produce a lot more for everybody and create that abundance, economics itself fundamentally breaks because economics is the study of scarcity, right? So I think it's a very hard question, and I don't think anybody has the answers right. Everyone's speculating on what this would look like, but it's not that humans would go away. I think we just evolve into a very different species with different understanding. So I don't think it's about new jobs being created and new skill sets. It's just that we will exist in a very different way. And if brain-computer interfaces also, penetrate fast enough, we will be connected to the AI and we'll be a different species altogether.
I think you folks have also posted top results on MLE Bench as well. For those who may not be familiar with it, what is that benchmark and why does it matter? as a measure of real capabilities?
So I think it's very important. Emily Bench is a very, very important benchmark because it actually is a benchmark that measures the AI and AI agents' capabilities to actually build new machine learning and AI models, right? So it's actually interesting because well, we've been using AI, for the last decade or 2 decades now in public, like the public and consumers have been using. Your Google Maps has AI, your auto completion of text, which was there in emails, had AI. The algorithms that are on social media have AI, right? So it's not that AI has not been there. It's just that it's become a lot more obvious with LLMs. Now, the thing is, all of these systems were built by human ML engineers and researchers, right? Even some of these, quant finance firms run on a lot of these models, right? Now, Emily Bench is actually a set of problems that have been accumulated over time of machine learning problem statements, right? And this benchmark was actually put out by OpenAI. Now, the interesting thing is, over the last 1 or 2 years, ever since this benchmark has come out, a lot of companies have been building ML research focused agents, which are very specialized agents to try to solve these problems. And over time, we saw that, okay, the capabilities of these agents are improving, and newer models and agents are getting better at it. But the interesting thing was when we ran our general purpose self-improving agent on it, which was, in fact, our agent is not specifically trained to solve this problem, right? Because it's a self-improving system. It actually figured out how to build a better agent than what some of these other companies and humans and researchers who are actually building these other agents, right? It self improved not just to the top of Emily Bench. It actually kept improving and beat its own previous version and its previous version. So it's, in a way, it's a non-stop recursive loop, right? It can get better and better, and now it's like Michael Phelps winning the world record and then saying that, okay, he's not competing with anybody else, he's just competing with himself in the clock, and he keeps just getting better and better, and he beats his own world record, right? It's something like that the agent is just getting better and beating itself now. And in fact, the interesting thing is the top three position was our agent.
And now I'm going to ask you a kind of uncomfortable question. As much as I also feel that things will move forward, but we have seen in some cases a very good example, EV. There are a lot of progress made, and then, of course, I don't want to name any company. They change their positions. They don't even talk about green earth anymore, and then the whole kind of momentum is slowing down because of all the lot of policies, infrastructure. When it comes to AI, one of the biggest pushbacks we are hearing is the data center buildup. The kind of, and a lot of FUD is also there. Plus, it doesn't seem like a very sustainable model where you are consuming so much energy, you have to build so much, and even system resources. You need very powerful machines for that. Of course, quantum is coming; it will come. Of course, political, technical, social, cultural, a lot of pushback is also happening here. A lot of We used to talk about Moore's law, but we don't talk about that anymore because the way chips are growing is exponentially. What are some of the challenges that you see in reaching superintelligence, and which challenges are less to do with the AI? It has more to do with technological limitations, resources, humans, politics.
Yeah, I think so. Again, right? Like it's that we are kind of reaching the point where we have the algorithm capabilities in place, right? Like, for example, like if you have a self-improving system and it figures out and it has awareness about its own system properties, right? Which means, okay, what are the kind of resources I'm consuming to be able to get what I want to do? It will improve itself. It will make itself more efficient to be able to work with those systems, right? With those limitations. I think the biggest bottleneck is the humans right now, right? And everything that you mentioned is a human problem, right? Whether it's the policies, whether it's the lack of resources that we are able to create because of human limitations. If a human can work 8 to 10 hours a day, an agent isn't limited by that, right? It'll be able to kind of speed things up. So I think even some of these problems, if we're able to kind of work with these systems to make them understand that these are the problems, they will find interesting solutions that even we can't find. But yes, it's the human realities which are truly the bottleneck, and that's why I think self-improving systems is the future in the way that they will figure out how to solve some of these problems as well, faster than we can.
Kunal, this has been a genuinely thought provoking conversation. The idea that we are moving from AI that does what you tell it to do to AI that improves itself without any human intervention. That is a fundamental shift in how we think about intelligence, progress, and superintelligence. Thank you for sharing where Hexo Lab is headed and letting us into the work that you folks are doing. And I encourage everyone who is watching to go and check out hexo.ai. And Kunal, once again, thank you for your time. And I look forward to chat with you again. Thank you.
Thanks, Swapnil.